Okay, here's our lesson on solving inequalities 2.1c. And we are going to fill out this table that looks at the differences and similarities between solving equations versus inequalities, because we just did equations last week. And so some of those steps are going to be exactly the same today, and some are going to be different. So we're going to start by solving these two. You'll notice that everything is the same about these two things, except one has an equals, so we call it an equation, and one has an inequality symbol, so we're going to call that an inequality. And last week we reviewed how to solve problems like this. We start by adding 4 to both sides. So I'm going to go ahead and do that to both sides of my equation and my inequality. You take a second and do that as well. So we should be here. On the left, negative 7 over 6x, and on the right, 21. Now, to handle the negative 7 over 6, there's 2 ways we talked about that you could do that. The first is you could multiply by the reciprocal, which is negative 6 over 7, and you could do that to both sides. The second way we talked about it is you could do it in 2 pieces. You could start by multiplying both sides by 6, and then dividing both sides by negative 7. You go ahead and take a second and do whichever method you like to both sides of the equation and the inequality. I'm going to do multiply by the reciprocal. Either way you go, you're going to end up having to do 21 times negative 6. Because remember okay, let me back up a second. If you're multiplying by the reciprocal, remember that 21 is over 1. And when you multiply fractions, you go across the top and across the bottom. So I'm going to have to do 21 times negative 6. So 1 times 6 is 6, and then 12. So that's negative 126. And then the denominator is 1 times 7. So now I need to do 126 over 7. I'm going to divide that. 7 goes into 12 once, with a remainder of 5. Bring down your 6, and 7 goes into 56, 8. And if you're dividing with different signs, you get negative answers. So I have x equals negative 18. Now doing that over here, the math is going to be the same. So I'm still going to end up with x on the left and negative 18 on the right. But here's the new part of today's lesson that we didn't have to do with equations. When you multiply both sides by a negative, you flip the inequality symbol. And we're going to talk more about that at the bottom of the notes. But for right now, just pay attention to us doing that we did that. We flipped the symbol. All right. So a few things I want to talk about as we compare and contrast equations and inequalities is what the graphs of their solution set look like and how they're different. They're both going to have a 0. Well, I'm sorry. You don't necessarily have to have the 0, but they're both going to have a negative 18 on their number line. And for an equation, it's just going to be a dot right here. There was one solution to that equation, and it's right here. This is the only number value for the solution is negative 18. But for the inequality, we want x represents all the numbers that are bigger than or equal to negative 18. So we still have the equal closed circle, but all the numbers that are bigger, remember this. So this represents all the numbers bigger than or equal to negative 18. So we're going to shade this way. So we would say that the equation has the number of solutions it has is 1. And for the inequality, it has infinitely many. Because this shaded section represents all the solutions to this inequality. I could find infinitely many numbers here because it goes out to positive infinity. For symbols on the equation, we just have this one symbol. For inequalities, we have 4 different ones. Less than or equal to, greater than or equal to. And then for other information, I don't have any other information for equations. But for inequalities, I want you to write this down. Flip the symbol when multiplying or dividing by a negative number. And then down here, I'm just going to give you a little example of how flipping the symbol helps us. So I'm going to write this little equation here and this little inequality here. Now these, oh sorry, I said inequality and I wrote it. Now both of these are true statements. And on an equation, if we do the same thing to both sides, then our answer is still going to be a true equation. So I multiply both sides by -3, for example. I will have -15 equals -15, which is still true. Now here's what happens on the inequality if I multiply both sides by -3, but don't flip the sign. Okay, so now on the inequality, let's see what happens when we multiply both sides by -3, just like we did on the equation, and we don't change the sign. We end up with this situation, a statement that says -15 is greater than -9. This is not a true statement. So imagine where those numbers are on a number line. Because -15 is to the left of -9, we know that -15 is smaller than -9. It is less than -9. And so we fix this statement from above by flipping the symbol when we multiply by a negative number. And we're going to do the same thing if we divide both sides by a negative number.